Okay, number 12, and they tell us that the population is skewed. Oops. Come on. Okay, and then they want to know why is it okay to use this data. Now remember, we need it to be random, we needed it to be less than 10%, and we needed to come from a normal distribution. Okay, and since n is greater than 50, n is greater than 30, we have a normal distribution due to the CLT. Due to the CLT. Okay, so the standard deviation of our 50 homes in a sample is 25,500. Okay, specify the sampling shape. Okay, so the shape of it is the t distribution. The mean they told us was $235,700, and the spread. Now remember, we have the standard deviation of our sample, not of the population. So it's going to be 25,000 divided by the square root of 50. And whatever that is equal to, that's your answer. Okay, you can keep it like that, or you can tell me the dollar amount. But the deal is that you can remember to divide by the square root of 50. Okay, so they give us this confidence interval, and this interval provide evidence that is unusually high. Okay, so what I'm asking you is our mean inside here? And so it is, isn't it? So this is proof that it's no, since our mean is in R, since our sample mean is in the confidence interval. Now I'm abbreviated, I don't have a lot of space, okay, you shouldn't abbreviate. Suppose we improve our estimate by choosing a new sample. How many home prices must we survey to have 90%? Okay, so we need to solve for n. So you need to remember that the formula for confidence intervals is estimate plus or minus the margin of error. And it's also going to be the mean plus or minus t star times the standard deviation of the sample divided by the square root of n. And so what do we know? That the margin of error is equal to t star times the standard deviation of the sample divided by the square root of n. So we want to solve for the square root of n. So that means I need to know my margin of error, I need to know my t star, and I need to know my standard deviation. The 2,000 is my margin of error. My standard deviation, they told us, was 25,500. And so I need to know my t star. Now, if I was to go to inverse t, to go that, notice that we need to know our degrees of freedom. And in order to do our degrees of freedom, we have to do n. We don't know what n is. So we're going to punt, and we're going to use z-score. So when you solve for n, for a t distribution, you use a z. So 90%, and that's going to be times 1.64. All right, so I'm going to go to the next slide, and I'm going to solve for this. So I have 2,000 plus or minus 1.64 times, 25,500 divided by the square root of n. Okay, so I'm going to divide both sides by 1.64. Okay, so look what happens. I divided it by 1.64, and I got 1219.51, and I got a long decimal. I'm keeping that number in my calculator. Now, remember what happens when our variable is in the denominator. It just switches to now what I have written in red. Again, my denominator is still in my calculator. So I'm going to say 25,500 divided by my answer. And so I get the square root of n is equal to 20.91. And so now I'm going to square n. And so I get n is equal to 437.22. Okay, do you see how I got that answer? I see what it says, but then I'm going to say 437 homes. Okay?